Hello, friends. You're welcome to another lesson today. In the previous lesson or exposition, we worked on addition and subtraction of surd and multiplication of surd. We worked on basic operations in surd, and we are given a couple of assignment, a couple of questions to go test or try ourselves with. So today we're going to be looking at the solutions for those questions we are given. So today we'll tell if we understood what we worked on in the previous exposition or not. So the very first question we were given was this question, this root 27 minus 3 plus root 28 minus root 75 minus root 63. Don't forget that when it comes to addition and subtraction of surd, there's no way we can combine two or more surds together if the radicands are not identical. So first we have to do is to break down each of this. These are all pure surds. This root 27, root 28, root 75, and root 63. So let's break down each of them. This root 27. Root 27 is 3 times 3 times 3. So we work on that. We're trying to convert each of this to mixed surd. So this will give us 3 root 3. That's nice. So the next we have is root 28. When we break this down using our table, we end up having 2 times 2 times 7. 2 times 2, 4. 4 times 7 is 28. So take these two that are partners. This one doesn't have a partner, stays in the root. 2 root 7. That is clear. So the next one is root 75. We're going to work on root 75. When we break this down, we end up having 3 times 5 times 5. 3 times 5 is 15. 15 times 5 is 75. So this 2, we have a partner here, pick out 1. This 5. This doesn't have anybody. This stays in the root. 5 root 3. So the next thing we do now is this the 3. We have to work on the 6 and 3. The 3. If we work on this, we end up having 3 times 3, which is 9. 9 times 7 is 63. Bring down this 2, which is 3. This doesn't have a partner, stays in the root. 3 root 7. So at this very point in time, the next thing we do now is to carry on. We bring them all together. So this root 27, which is 3 root 3 minus 3 is right here. This is just a major rational number, just single on its own. And then root 28, that's 2 root 7. Then root 75 minus 5 root 3. Then minus root 3 is minus 3 root 7. So all is set. The next thing we just have to do is to bring together or collect our like terms, all the ones with the same radicand we brought together. So this 3 root 3 here, we go with this one here. So this 3 root 3 minus 5 root 3, then plus 2 root 7. We go with minus 3 root 7. So this one has nobody, just stays out on its own. So these two are the same. That's why it's very possible for us to solve them together. So this plus 3 minus 5 plus 3 minus 5 will give us minus 2 root 3. That is sorted. Then plus 2 minus 3 will give us minus 1 root 7. Then minus 3 out here. So what do we have? The next thing we have, we're done with this already. So this minus 2 root 3 minus root 7. Then minus 3. There's no way we can combine these two because they are different radicands. So at the very point in time, this is our final answer. So if you got this as your final result, it means you understood all what we discussed in the previous exposition. Okay, number 2 question. 5 root 3 minus root 2 plus 1 in bracket. Then another bracket, 2 minus 3 root 3 minus 5 root 2. So we are asked to solve this. In the previous exposition, this was the second question we were given. So how do we solve that? How do we expand this? Don't forget that when it comes to multiplication and division, we don't really care if we have the same radicand or not. We having the same radicand is very, very important when it comes to addition and subtraction. But when it comes to multiplication, the radicands don't really matter because we solve the rational numbers separately and we solve the radicands separately. So the first thing we're going to do now is to take 5 root 3 to multiply each of this one after the other. When we're done with that, the next thing that we take our root 2 to do the same thing to them, and then our 1 does the same thing to them. So 5 root 3 first, we'll talk to each of them. So that'll be 5 root 3 times 2. This is a pure rational number, doesn't have any radicand at all. So what do we have here? This 5 times 2, 10 root 3. We're done with that. So the next is 5 root 3 times this. This 5 root 3. Don't forget that this 5 has a positive sign. Times, you have to be very careful with their signs. You have to move them out with the signs if possible. So that's minus 3 root 3, so plus and minus is minus. 5 times 3 is 15. Root 3 times root 3 is root 9. So what do we have next? This minus 15, square root of 9 is 3. 15 minus 3, 15 times 3 is minus 45. So we're done with that, we sorted that. So the next 5 root 3 times minus 5 root 2. So plus 5 root 3 times minus 5 root 2. Let's be careful with the signs. Plus and minus is minus. 5 times 5 is 25. Root 3 times root 2 will give us root 6. We're done with that also. So we're done using 5 root 3. So the next thing you're going to do is we're going to be using our minus root 2. So our minus root 2 also, we talk to this, and talk to this. So just going to be that very cycle until we are done. So minus root 2 times 2. So this times plus 2. That will give us minus. This doesn't have any radicand. But yeah, it's minus 1. So minus 1 times 2 is minus 2. Then put your root 2. We're done with that. So minus root 2 times this. Minus root 2 times minus 3 root 3. Please, our signs have to be very, very taken care of. You have to really be careful with the signs. You have to pay a whole lot of attention to. So, so yeah, we have minus here. So we bracket this. Minus and minus first, plus. This doesn't have any major rational number, but we know that has 1. So 1 times 3 is 3. Root 2 times root 3 will give us root 6. We're done with that. So the next minus root 2 times minus 5 root 2. This root 2 here, you can put this in brackets. So this root 2 here has 1. We know that already. So minus and minus first, you work on the signs first. That's plus. 1 times 5. 5. Root 2 times root 2 is root 4. So that's plus 5. Square root of 4 is 2. 5 times 2 is 10. We are done with that also. So we're done using root 2. So the last thing we're going to use now is plus 1. So plus 1 times ordinary 2, this plus 2 here. Plus 1 times plus 2 give us plus 2. Correct? So plus 1 times this. Times minus 3 root 3. This doesn't have any radicand. Well, first of all, let the signs talk. Plus and minus is minus. Then 1 times 3. You give us 3. Just the root 3 stays out. That is sorted. So the next plus 1 times minus 5 root 2. So plus and minus is minus. 1 times 5 is 5. Then root 2. So we're done with all this. We've worked on all of them. We've broken them down. So the next thing you're going to do is to bring them all together. So the first we have is 10 root 3. And after that, the next we have is minus 45. And after that, the next we have is minus 25 root 6. So that's that for the first set. So after that, let's go to the second set, minus 2 root 2. Then the next, plus 3 root 6. So the next one is plus 10. So we're done with that. So the very last set, this is plus 2. After that, minus 3 root 3. Then the very last one, minus 5 root 2. So it's high time we got our like terms collected. So this 10 root 3. This 10 root 3 here. Another root 3 again. Another root 3. So 10 root 3 minus 3 root 3. Then the root 6 comes in next. This root 6 here and root 6 here. So that will be minus 25 root 6 plus 3 root 6. So we're done with that. So what else do we have? We've collected this root 3 and root 3 being brought together. Root 6 and root 6 being brought together. Okay, we have root 2 minus 2 root 2 right here. Minus 5 root 2. So we are done with all the ones with radicands. Now the ones without any radicands, minus 45. Then plus 10. Then plus 2. So minus 45 plus 10 plus 2. So let's combine all of them together. So 10 minus 3. Now this ones we can combine them because they have the same radicand. Plus 7 root 3 minus 25 plus 3 will give us minus 22 root 6. Minus 2 minus 5 will give us minus 7 root 2. Then we're done with all that. Then the ones without radicants, minus 45 plus 10 is minus 35. Minus 35 plus 2 is minus 33. So these are our final results. And there's nothing you can do here. They have different radicands, even though this one could be broken down to root 2 times root 3. So that's a way we can factorize, but we can't go beyond this level really. Why? Because the radicands are different. So if you got this very answer, it means you understood what we took in the previous exposition. So at this very point in time, we'll be drawing the curtain of today's exposition. So if you found this resourceful, please subscribe to this very channel and share this exposition. Thanks.